So for Lorenz curve and Gini index, it's a curve which we can study more in the detailed way. The dispersion of, or the concentration of the character of the statistical study of in this case the height. So in order to do that, we have here the center of class already having here, yes, and the thing we do is to actually calculate what is called the mass. The mass, because we have here unequal differences between intervals. So here we have 5, 7, 8, 5. So we calculate what is called the mass of the class. The mass. How we calculate it? Equal to center of class multiplied by the number of in all these intervals of height. So it's 0 here multiplied by center of class. Here we have 182.5. we generate that. The second thing we do is to calculate the cumulative the cumulative of it, cumulative mass. But in percentile. So here we have, we should in order to calculate it, cumulative mass. So just cumulative mass, which is here we have 0. Here we have this one plus here equal to, and we generate that. So to the total of it, the total of mass is 3066.6 0.7. So we calculated it as a total. We enter it as a total of it. So what we're gonna do now is the frequency. We're gonna calculate the cumulative mass in percentile. Cumulative mass in percentile. So, which is here, divided by to fix the G7, the G7, we're gonna take dollar here and dollar here. We generate that. We took only 2 after the point. No. That's it. So, in order to calculate now we're gonna calculate the Lorenz curve. So to do that, we select the frequency, the cumulative frequency, and the cumulative mass of numbers. So we're gonna right click here. We're gonna do a right click here. Select that. Now in the left click. Then we enter Control in our keyboard. and select the second one. We search here for insertion and graphics. We enter the graphic here. So the thing here, what we can observe in this case, that it's something that there is not a lot of variations. There is, so that means the distribution of the heights between the athletes, it's not this it's not it's not, there is not a level or variance of it. It's concentrated. So the first thing we're gonna do after obtaining these graphics is adding the legends. So the legend here, we call it so we should have here the, it's equal to what, equal to we're gonna add something here which is called the series, which is called the line 0110, which is called letter, in French, letter what. So we're gonna calculate it here. We're gonna add here 0 between accolades, 0 1 here, and same thing here. We click OK. So this is the whole the route here. So we're gonna call it here we should for the serial one, which is called cumulative this number of swimmers per height and here cumulative. No, this is the cumulative of, here, number of swimmers, and here we have cumulative of the height of the swimmers. So what does what does it mean? So this is mean there is not a lot of variations exist. Okay, so we're gonna take this. This is not mean we're gonna the simple thing we're gonna say that is there is nothing we can what is called say about this graphics, because the dispersion is approximately 0 here. So we're gonna take this graphics to the word and analyze this statistical values of quartile, the variance, and the equartile. So we're gonna copy this graphics. We're gonna go to Word. Here. So now we're gonna it's still something about all this data that we analyze the whole value in the whole value of it. So in the case of studying the height of the final the athletes that are finalists of 50-meter freestyle on extent of 25 centimeter, we observe that the mean of it is, here we have the mean is 193.53. The most repetitive value is here, which is the mode. Here we have 192.13 centimeter. For the median, we said 50% of the swimmers have a height higher than 193.13 centimeter, and 50% have a height less than let's repeat it 193 13 centimeter. For the quartile, 25% of swimmers have a height smaller, let's say smaller than 182 and 89.16 centimeter. For the quartile, 75, have a height less than 187.55 centimeter. Let's talk about here about the variance in the e-quartile. 22.01, which means there is a lot of variation exists between the different class of a height. We have a standard deviation equal to 4.69, which means the swimmers gave so much importance to their height in order to be competitive on this discipline. So, in conclusion, you can say that in this case the different values of heights of the swimmers is exaggeratedly concentrated. So I'm gonna upload this so don't bother with this. I'm gonna upload this file of Word into the course so you can check it.